Now start with another part, chapter 1, electric charges and field, part 4, class 12th physics. First topic is electric flux. Electric flux is the angle delta phi equals to E dot delta ds, or we can say that E dot ds cos theta, where theta is the angle between electric field E and area element vector delta s, where inward flux is negative, outward flux is positive. We have delta s and E angle theta, where SI unit is nc minus 1 m square and it's a scalar quantity. So E dot ds cos theta. Now Gauss law states that the electric flux through a closed surface S is equals to the q by epsilon naught, where q is total charge enclosed by S, where q is the total charge enclosed by, and in center r is the radius, delta s and r vector. Electric flux through this area element is delta phi equals to E dot ds equals to, putting the value of E, q by 4 pi epsilon naught r square r dot ds, where E equals to q by epsilon naught r square r vector as per Coulomb's law, where unit vector r is enclosed with the radius vector from the center to the area element. Area element vector has direction perpendicular outside the area ds, which is also direction of r vector. So r dot ds equals to r dot delta s r arrow, which is equals to delta s. So r dot r equals to 1, then we get delta phi equals to q by epsilon r square ds. Then total flux equals to summation for all ds q by epsilon naught r square delta s. So for summations, delta s equals to s, which is equals to 4 pi epsilon naught 4 pi r square, which is the area of sphere. Then phi equals to q by epsilon naught r square into 4 pi r square. Then we get q by epsilon naught, which varies the Gauss law. Now applications of Gauss law. First is electric field due to an infinity long straight uniformly charged wire. At first start with, consider a thin straight wire with uniform linear charge density lambda. Nature of electric field on Gaussian surface is radially outward. ये क्या होगा? Radially outward. The surface area of the curved part is 2 pi r l, where l is the length of the cylinder. Here L is the length of the cylinder, positive charges, r is the radius between them, P and E vector. Now electric flux through the total Gaussian surface phi E dot ds equals to E ds cos 0 हो जाएगा. Then E बाहर आ जाएगा इंटीग्रेशन ds, which is 2 pi rl into E, or we can say that E here putting. Now the surface include charge equals to lambda l. Surface include, surface क्या को include होगा? Charge equal to lambda l. Hence Gauss law gives E 2 pi rl equals to lambda l by epsilon naught. Therefore we get E equals to lambda 2 pi epsilon naught r. Vectorially E at any point is given by E equals to lambda 2 pi epsilon naught r and vector, where n vector is the radial unit vector, n is radial unit vector to the wire, and E is directed outward. If lambda is positive and inward if lambda is negative. That's why E is directed outward if lambda is पॉजिटिव. लैम्डा अगर पॉजिटिव होगा तो ई क्या होगा? डायरेक्टेड आउटवर्ड. एंड ई इज डायरेक्टेड इनवर्ड इफ लैम्डा इज नेगेटिव. ओके. The next is uniformly charged infinite plane sheet. Here we have a plane sheet with, let sigma be the uniform surface charge density of an infinite plane sheet. The unit vector normal to the surface 1. We have surface 1 is in minus x direction, and while 2 is in plus x direction. Therefore flux E dot ds through both the surfaces are equal and add up. Then the net flux is 2EA. So by Gauss law we have 2EA equal to sigma A divided by epsilon naught. So or we can say that E is equals to sigma 2 epsilon नोट, बिकॉज ई से ई कैंसिल हो जाएगा, ये ए है. और वेक्टोरिकली वी कैन से दैट ई वेक्टर इक्वल्स टू सिग्मा डिवाइडेड बाय 2 एप्सिलॉन नॉट एन वेक्टर. ओके. So therefore for a large plane sheet expression E is equals to sigma by 2 epsilon naught will be approximately true and middle region of the planar sheet. Now for uniformly charged thin spherical shell, in thin spherical shell first is outside the shell Gaussian surface होगा, Gaussian charge density sigma here, and ds E p r is the radius, O is the center, r is the radius between them. Now electric field is radially outward, E and ds at every point is parallel, and flux through each area element is E dot delta S summing overall. So delta S in Gaussian surface is E dot 4 pi r square. So by Gauss law we have E 4 pi r square is equals to sigma 4 pi r square divided by epsilon naught, because sigma is equals to q by 4 pi r square. So E equals to sigma r square divided by epsilon naught r square equals to q divided by 4 pi epsilon naught r square, where q is the total charge. q क्या होगा? Total charge on spherical shell. Or in vectorial we can say that E vector equals to q divided by 4 pi epsilon naught r square r vector. Electric field is directed outward. Electric field directed होगा outward if q is greater than 0 and directed inward if q is less than 0. So E is equals to q divided by 4 pi epsilon naught r square, just derived above exactly. And for inside the shell we have Gaussian surface enclosed, no charge. Then E dot 4 pi epsilon naught equals to 0, that is E equals to 0, small r is less than capital R. Thus field due to uniformly charged thin shell is 0 at all points inside the shell. Okay.